Hello and welcome to part 6 of our AWS Certified CloudOps Engineer Associate Ultimate course. Friends, we are starting with question number 53 in this part of our series. A CloudOps engineer manages a company's Amazon S3 buckets. The CloudOps engineer has identified 5 GB of incomplete multi-part uploads in an S3 bucket in the company's AWS account. The CloudOps engineer needs to reduce the number of incomplete multi-part upload objects in the S3 bucket. Which solution will meet this requirement? Your options are: create an S3 lifecycle rule on the S3 bucket to delete expired markers or incomplete multi-part uploads. Require users that perform uploads of files into Amazon S3 to use the S3 transfer utility. Enable S3 versioning on the S3 bucket that contains the incomplete multi-part uploads. Create an S3 object Lambda access point to delete incomplete multi-part uploads. Now folks, incomplete multi-part uploads happen when a client initiates an upload but never completes it. These parts take up space and can accumulate costs. S3 lifecycle rules let you automatically clean these up by configuring an abort incomplete multi-part uploads action after a set number of days. Now, S3 transfer utility used in option B is a client-side utility that helps complete uploads efficiently. Option C involves enabling S3 versioning, which controls object versions. And option D involves S3 object Lambda access point, which is used to transform object data on retrieval, not for cleaning up incomplete uploads. Next question. A company has an encrypted Amazon S3 bucket that is hosted in the AP Southeast 2 region. Users from the EU West 2 region access the S3 bucket over the internet. The users from EU West 2 need faster transfers to and from the S3 bucket for large files. Which solution will meet these requirements? Your options are: reduce the length of the S3 bucket prefixes within the S3 bucket, change the server-side encryption on the S3 bucket from AES to RSA, create a new S3 bucket that has an identical name in EU West 2. Use the new S3 bucket endpoint's domain name for access. Enable S3 transfer acceleration on the S3 bucket. Use the new S3 accelerate endpoint's domain name for access. Now folks, the problem statement here is users in EU West 2, which is London, are accessing an S3 bucket in AP Southeast 2, which is Sydney, over the internet. For large files, this results in high latency and slower transfers, and the best solution would be to use S3 transfer acceleration. Now, Amazon S3 transfer acceleration leverages Amazon CloudFront's globally distributed edge locations, and data is routed over AWS optimized network backbone to the buckets region, reducing latency for long distance uploads or downloads. Users in London will connect to the nearest edge location, and AWS carries the data across its backbone to Sydney. Question number 55. A CloudOps engineer needs to deploy an application in multiple AWS regions. The CloudOps engineer must implement a solution that routes users to the region with the lowest latency. In case of failure, the solution must automatically route requests to a region with a healthy instance of the application. The company needs a solution with the shortest time to failover. Which solution will meet these requirements? Your options are: create Amazon Route 53A records that have the same name for each endpoint, use a latency routing policy, associate a health check with each record. Create Amazon Route 53A records that have the same name for each endpoint. Use a failover routing policy. Associate a health check with each record. Create an AWS Global Accelerator Standard Accelerator. Create an endpoint group for each region. Add a listener to the accelerator. Associate the endpoint group with the listener. Create Amazon Route 53A records that have the same name for each endpoint. Use a geolocation routing policy. Associate a health check with each record. Now, folks, you can automatically rule out all the options, including Route 53 in the solution, as it is a DNS-based solution. So client cache DNS answers based on TTL, leading to slower failover compared to global accelerators, edge-based health checks and routing. Now, Global Accelerator uses anycast static IPs and routes users to the nearest healthy endpoint over the AWS global network. Health checks and traffic shifting happens at the edge, typically failing over in seconds, not waiting for DNS cache or TTL. Next question. A company's CloudOps engineer manages a fleet of hundreds of Amazon EC2 instances that run Windows-based workloads and Linux-based workloads. Each EC2 instance has a tag that identifies its operating system. All the EC2 instances run AWS Systems Manager Session Manager. A zero-day vulnerability is reported and no patches are available. The company's security team provides code for all the relevant operating systems to reduce the risk of the vulnerability. The CloudOps engineer needs to implement the code on the EC2 instances and must provide a report that shows the code has successfully run on all the instances. What should the CloudOps engineer do to meet these requirements as quickly as possible? Now the options are: use Systems Manager run command, choose either the AWS run shell script document or the AWS run PowerShell script document, configure run command with the code from the security team, specify the operating system tag in the tags parameter, run the command, provide the command's history evidence to the security team. Next option is create an AWS Lambda function that connects to the EC2 instances through Sessions Manager. Configure the Lambda function to identify the operating system, run the code from the security team, and return the results to an Amazon RDS DB instance. Query the DB instance for the results. Provide the results as evidence to the security team. Now the third option is log on to each EC2 instance, run the code from the security team on each EC2 instance, copy and paste the results of each run in a single spreadsheet, provide the spreadsheet as evidence to the security team. And friends, the last option is update the launch templates of the EC2 instances to include the code from the security team in the user data. Relaunch the EC2 instances by using the updated launch templates. Retrieve the EC2 instance logs of each instance. Provide the EC2 instance logs as evidence to the security team. Now friends, AWS Systems Manager run command is designed to run scripts or commands at scale across Windows or Linux EC2 instances. You can target instances by tags. In this case, it will be operating system tag. Choose the right SSM document, which is AWS run PowerShell script for Windows and AWS run shell script for Linux. It provides a built-in execution history and logs for auditing or compliance, which can be exported to share with the security team. Friends, if you're liking the content, do not forget to hit the like button and subscribe the channel. Let's look at question number 57 of the series. A company is trying to connect two applications. One application runs in an on-premise data center that has a host name of host1.onprem private. The other application runs on an Amazon EC2 instance that has a host name of host1.aws cloud private. An AWS site-to-site VPN connection is in place between the on-premise network and AWS. The application that runs in the data center tries to connect to the application that runs on the EC2 instance, but DNS resolution fails. A CloudOps engineer must implement DNS resolution between on-premise and AWS resources. Which solution allows the on-premise application to resolve the EC2 instance host name? Your options are: set up an Amazon Route 53 inbound resolver endpoint with a forwarding rule for the on-prem .private hosted zone. Associate the resolver with the VPC of the EC2 instance. Configure the on-premise DNS resolver to forward on-prem.private DNS queries to the inbound resolver endpoint. Now the second option is set up an Amazon Route 53 inbound resolver endpoint. Associate the resolver with the VPC of the EC2 instance. Configure the on-premises DNS resolver to forward AWS cloud.private DNS queries to the inbound resolver endpoint. Third option is set up an Amazon Route 53 outbound resolver endpoint with a forwarding rule for the on-prem.private hosted zone. Associate the resolver with the AWS region of the EC2 instance. Configure the on-premise DNS resolver to forward on-prem.private DNS queries to the outbound resolver endpoint. And the fourth and final option is set up an Amazon Route 53 outbound resolver endpoint. Associate the resolver with the AWS region of the EC2 instance. Configure the on-premise DNS resolver to forward AWS cloud.private DNS queries to the outbound resolver endpoint. Now, folks, outbound resolvers are for AWS to reach external DNS. However, here the ask is on-premise to AWS resolution. So you can rule out option C and D, which primarily use outbound resolver. An inbound Route 53 resolver endpoint accepts DNS queries that originate outside AWS, for example, on-premise, and forwards them into your VPC. Now, option A involves setting up an Amazon Route 53 inbound resolver endpoint with a forwarding rule for the on-prem.private, which is incorrect as it already knows about its own namespace and you need the ability to resolve AWS cloud.private, which is what makes option B as the correct choice. Folks, as you would have seen, elimination approach made this question very easy. So always try to follow this approach where possible. Next question. A developer creates a web application that runs on Amazon EC2 instance behind an application load balancer. The instances are in auto-scaling group. The developer reviews the deployment and notices some suspicious network to the application. The traffic is malicious and is coming from a single public IP address. A CloudOps engineer must block the public IP address. Which solution will meet this requirement? Your options are create a security group rule to deny all inbound traffic from the suspicious IP address. Associate the security group with the ALB. Implement Amazon Detective to monitor traffic and to block malicious activity from the internet. Configure Detective to integrate with the ALB. Implement AWS Resource Access Manager to manage traffic rules and to block malicious activity from the internet. Associate AWS RAM with the ALB. Add the malicious IP address to an IP set in AWS WAF. Create a web ACL. Include an IP set rule with the action set to block. Associate the web ACL with the ALB. Now friends, AWS WAF is the correct service for blocking malicious traffic at the ALB layer. With WAF, you create an IP set that contains the malicious IP address, add a rule in a web ACL to block that IP set, and associate the web ACL with the application load balancer, resulting into all requests from that IP getting blocked before reaching the backend EC2 instances. Next question. A company runs its entire suite of applications on Amazon EC2 instances. The company plans to move the applications to container and AWS Fargate. Within 6 months, the company plans to retire its EC2 instances and use only Fargate. The company has been able to estimate its future Fargate costs. A CloudOps engineer needs to choose a purchasing option to help the company minimize costs. The CloudOps engineer must maximize any discounts that are available and must ensure that there are no unused reservations. Which purchasing option will meet these requirements? Your options are compute savings plan for 1 year with the no upfront payment option, compute savings plan for 1 year with the partial upfront payment option, EC2 instance savings plan for 1 year with the all upfront payment option, EC2 reserved instances for 1 year with the partial upfront payment option. Now folks, EC2 reserved instances and savings plans are only applicable to EC2 instances and won't be of any use once the company moves to AWS Fargate in next 6 months, so you can rule them out. Discounts offered by compute savings plan apply to any compute usage including EC2, Lambda and Fargate, making them the right fit here. Now the question is whether to use no upfront payment option or partial upfront payment option. I think partial prepayment may offer higher discounts here, making option B as the correct choice. Now, question explicitly states the company has been able to estimate its future Fargate costs, which is why I think it's better than no upfront payment option in this case. Question number 60 of the series. A company is using an Amazon DynamoDB table for data. A CloudOps engineer must configure replication of the table to another AWS region for disaster recovery. What should the CloudOps engineer do to meet this requirement? Your options are enable DynamoDB accelerator, enable DynamoDB streams and add a global secondary index, enable DynamoDB streams and add a global table region, enable point-in-time recovery. When you enable DynamoDB streams on a table and configure a global table, changes made to the table are recorded in the stream. By adding a global table region, you create a replica of the table in another AWS region. Any changes made to the original table are replicated asynchronously to the replica table in the other region. This setup provides disaster recovery by ensuring that if the primary region becomes unavailable, you can fail over to the replica in the other region. Now friends, there is a link on your screen. Go through the link to understand more about how you can use global tables in Amazon DynamoDB. Question number 61 of the series. A company runs its applications on a large number of Amazon EC2 instances. A CloudOps engineer must implement a solution to notify the operations team whenever an EC2 instance state changes. What is the most operationally efficient solution that meets these requirements? Your options are create a script that captures instance state changes and publishes a notification to an Amazon Simple Notification Service topic. Use AWS Systems Manager run command to run the script on all EC2 instances. Create an Amazon Event Bridge event rule that captures EC2 instance state changes. Set an Amazon Simple Notification Service topic as the target. Create an Amazon Event Bridge event rule that captures EC2 instance state changes. Set as the target an AWS Lambda function that publishes a notification to an Amazon Simple Notification Service topic. Create an AWS config custom rule that evaluates instance state changes with automatic remediation. Use the rule to invoke an AWS Lambda function that publishes a notification to an Amazon Simple Notification Service topic. Now folks, Event Bridge can directly receive the built-in EC2 instance state change notification events. So let's rule out option A and D here, which are more custom and require administrative overhead. You can route the events to a SNS topic, achieving the requirement with minimal configuration and making it a fully managed solution. Using Lambda would be unnecessary overhead here, as Event Bridge can send events directly to SNS. Next question. A company runs an application on Amazon EC2 instances that are in an Amazon EC2 autoscaling group. Scale out actions take a long time to become complete because of long running boot scripts. A CloudOps engineer must implement a solution to reduce the required time for scale out actions without over provisioning the autoscaling group. Which solution will meet these requirements? Your options are change the launch configuration to use a larger instance size, increase the minimum number of instances in the autoscaling group, add a predictive scaling policy to the autoscaling group, add a warm pool to the autoscaling group. Now friends, a warm pool keeps EC2 instances pre-initialized but in a stopped or running but not in service state. When scale out happens, these instances can be brought into service very quickly. This directly solves the problem of scaling out taking long time without over provisioning. Now option A introduces larger instances with more CPU and memory, but this does not reduce boot script execution time. Option B involves increasing the minimum number of instances in the autoscaling group. While it reduces scale out latency, but it means over provisioning, which we want to avoid. Option C uses predictive scaling, which uses historical patterns to launch instances ahead of time. This can help, but it doesn't solve the issue if workload is unpredictable. Question number 63 of the series. A company is managing multiple AWS accounts in AWS organizations. The company is reviewing internal security of its AWS environment. The company's security administrator has their own AWS account and wants to review the VPC configuration of developer AWS accounts. Which solution will meet these requirements in the most secure manner? Your options are: create an IAM policy in each developer account that has read-only access related to VPC resources, assign the policy to an IAM user, share the user credentials with the security administrator. Create an IAM policy in each developer account that has administrator access to all Amazon EC2 actions, including VPC actions. Assign the policy to an IAM user. Share the user credentials with the security administrator. Create an IAM policy in each developer account that has administrative access related to VPC resources. Assign the policy to a cross-account IAM role. Ask the security administrator to assume the role from their account. Create an IAM policy in each developer account that has read-only access related to VPC resources. Assign the policy to a cross-account IAM role. Ask the security administrator to assume the role from their account. Now friends, option A and option B involve sharing IAM user credentials, which is a bad practice and not secure at all. So let's rule them out. Option C and option D both involve a cross-account role assumption, which is better than user credentials, but the permissions for option C are too broad. Granting admin access when you just need read permissions is another bad practice. Folks, if you still have any doubts on why I have chosen option D as the correct answer, then please post them in the comment section. And friends, that's all for this part of the series. I'll see you soon in further parts of our AWS Certified CloudOps Engineer Associate Ultimate course. Friends, if you have not watched the previous parts of the series yet, then link to the playlist is available in the description section of the video. Make sure to go through all the videos to gain maximum benefits from our content.